Hello everyone, welcome to Electrical Engineering. Uh, I am Dr. S.K. Sonkar, Assistant Professor of EX Department, SIIT Bhopal. Today we discuss the fundamental of torque equations and equivalent parameters. So the subject is electrical drives. So fundamental of torque equations, when an electric motor rotates, it is usually connected to load which has a rotational or translational motion. The speed of the motor may be different from that of the load. Analyze the relation among the drives and the load, the concept of dynamics of the electric drives in the introduced. So here the diagrams here this one is the motor and the torque is the T and the speed is the omega m, and this one is the load and the torque is the T1, always opposite to the motor torque. So here J polar moment of inertia of the motor load and omega m instantaneous velocity and T instantaneous value of developed motor torque and T1 instantaneous value of the load torque referred to the motor short. Now the from the fundamental torque equation, T minus TL is equal to d by dt j omega m is equal to j d omega m by dt plus omega m dj by dt. So here for drives with the constant inertia, so dj by dt is equal to 0. So therefore the T is equal to T plus j d omega m by dt. The equivalent values of drive parameters are different parts of the load may be coupled through the different mechanisms such as the gears, V-belts, crankshaft. These parts may be different speed of different types of motions such as the rotational and the translational motion. This section presents the method of finding equivalent moment of inertia J of the motor load system and equivalent torque components, all refer to motor shaft. So here we find the load with rotational motion. Here let us consider a motor driving two loads, one coupled directly to its shaft and other through the gear with N and N1 is the teeth of the mechanism. Let the moment of inertia of motor and load directly coupled to its shaft by be J0. So motor speed and torque of directly coupled load be omega m and TL0 respectively. Later, the moment of inertia, speed and torque of the load coupled through a gear be J1 omega M1 and TL1 respectively. Now here the omega M1 by omega M is equal to N by N1 is equal to A1. Here A1 is the gear teeth ratio. This is the diagrams of the rotational motion, and this one is the translational motion. This one is the motor M and motor load TL0 and the inertia of the J0 and omega M, and the gear system gear system N and N1, that is the teeth ratio of A1. And this is the another load where the moment of inertia J1 and load torque is the TL1. And this one is the translational motion diagrams. If the losses transmission lines or transmissions are neglected, then the kinetic energy due to the equivalent inertia must be same. Is kinetic energy of various moving parts is the 1 by 2 j omega m square is equal to 1 by 2 j0 omega m square plus 1 by 2 j1 omega 1 square. So here the total moment of inertia J is equal to J0 plus A1 square J1. Power at the load and the motor must be same. The transmission efficiency of gear is eta 1, then the total torque TL omega m is equal to TL0 omega m plus TL1 omega m1 by eta 1, where TL is the total equivalent torque referred to the motor shaft. So here the total torque TL is equal to TL0 plus A1 TL1 by eta 1. If in additional to load directly coupled to motor with inertia J0 and the M load with the moment of inertia J1, J2 dot dot Jm and the gear teeth ratio of A1, A2 dot dot Am. Then the total moment of inertia J is equal to J0 A1 square J1 plus A2 square J2 plus dot dot Am square Jm square. J and if the M load with torque respectively by TL is equal to TL1 plus A1 L1 by eta 1 plus A2 TL2 plus eta 2 dot dash dash plus AM TLM by eta M. So second part is the rotational translational motion. Let us consider a motor driving two loads, one coupled directly to the shaft and other is transmission system converting rotational motion to linear motion. Let moment of inertia of the motor load directly coupled with the J0 and torque is the TL0 and the velocity and force of the load with translation motion V M1 kg and V1 meter per second and F1 is the force of the Newton respectively. If the translation laws are neglected, the kinetic energy due to the equivalent inertia J is the same of kinetic energy. So here 1 by 2 J omega m square is equal to 1 by 2 J0 omega m1 square plus 1 by 2 m1 v1 square. So here J is equal to J0 plus m1 v1 omega m square. Similarly, power at the motor and load shaft be the same. Thus, the efficiency of transmission is the eta 1. So, torque TL omega m is equal to TL0 omega m plus F1 V1 eta 1. So, the total torque TL is equal to TL0 plus F1 eta 1 bracket of V1 omega m.